Hey everyone, today we're going to do a little bit of a tricky problem with the Pythagorean theorem. So this would apply to grade 8 math when we introduced it at the beginning of the year, and we review the Pythagorean theorem in grade 9, grade 10, even grade 11. So I just think this is a really cool problem. So starting off with a diagram that you might be able to make sense of. So we have a triangle ABC that is equilateral. That means that all three sides measure 4 units long, okay? And then we have the point D down here that is the midpoint of line BC. So D is smack dab in the middle, meaning that BD and DC are the same length, okay? And lastly, point E is the midpoint of A and D. And so point E is smack dab here in the middle as the midpoint of this vertical line, okay? Now the problem asks us to find the length of EB squared, okay? So this length squared. So first things first, we might notice that the Pythagorean theorem will be useful in this problem because we have two nice right angles here, okay? And whenever we're dealing with right angle triangles, this is always a safe bet to go with. And so I'll first off state the Pythagorean theorem. A squared plus b squared is equal to c squared. This is you past grade 8, you're surely familiar with this. So from that point on, we might look for any right angle triangles that kind of pop out at us. And so I see one here as triangle ADB, and then similarly, because of the symmetry of an equilateral triangle, we have triangle ADC that is also a nice right angle triangle, okay? Which means we can apply the Pythagorean theorem. And so, if we look at these two bottom sides here, since the entire side length is 4, as ABC is equilateral, then this entire side length must also be 4. And since point D is the midpoint of this BC, then each one of these half segments have to be 2 units long, okay? So 2 units and 2 units. Now, it would be nice if we knew the length of line AD. And we can actually get it because this acts as one of the shorter legs of our right angle triangles on either side that we want to work with. And so we can start off by using the Pythagorean theorem with the bottom side length of 2, the hypotenuse on either side of length 4, and we can look for the vertical height, which would be the length of the line segment from A to D. And so if we want to write that out, we'll have 2 squared plus the line from A to D we'll write as AD squared is equal to the hypotenuse on either side being 4, and so equal to 4 squared. And now with some basic algebra, we can find that 4 plus AD squared is equal to 16. We're looking for AD squared, so we want to isolate it, and so we'll subtract 4 on both sides. And we find that AD squared is equal to 16 minus 4, which is 12. And so finally, if we want to get just the line segment of AD, we can take the square root of both sides to cancel out the square, always doing the same exact operation on both sides to stay equivalent. And we find that the length of the segment AD is equal to the square root of 12, okay? Now, you can approximate this using a decimal if you want to use a calculator and write out the decimal approximation. It'll be something like 3.46, so on and so forth. I'm gonna go ahead and introduce a concept that will be introduced around math 10, grade 10 math, and that's to say that we can write a square root as the square root of a product of its factors. And so 12 is 4 times 3, and so I'm gonna write the square root of 12 as the square root of 4 times 3, okay? Now the reason we do that is because there's a rule with square roots that the square root of a product can be written as the product of square roots, okay? So since 12 is 4 times 3, we write it as the square root of 4 times 3, and then we separate into 2 separate square roots, the square root of 3 times then the square root of 4. And the reason we're doing this is because the square root of 4 is a nice whole number. It's 2. And so this simplifies down to 2 root 3, okay? Now, the reason this is gonna turn out to be useful is because if we now know that this line segment here from A to D, AD, is a length of 2 root 3. You can kind of slide that in, 2 root 3. Then when we're looking for the line segment EB, right, which is ultimately what we're looking for in the end, we know that we have the bottom length of 2. And now, since point E is the midpoint of the line AD, and we know the length of the line AD, then we know that E is in the middle of this length. And so that means the bottom half of line AD is going to be exactly the length from point D to point E, right? And so we can state that ED is equal to 1/2 of AD, since E is in the middle as a midpoint, and so 1/2 of AD, and so ED is equal to 1/2 of, we found what AD was. AD was 2 root 3, and so 1/2 of 2 root 3, and now we're getting towards the end. 1/2 of 2 root 3, 1/2 of 2 is just 1, so those cancel out, and so we found that ED has a length of the square root of 3. And so that is now this little length here. And finally, you might notice already that what we have brewing here is another nice right angle triangle. We know the bottom side length is 2. We now know the vertical side length is root 3. And what we're looking for ultimately is the segment from E to B. Right, and that is the hypotenuse of this nice right triangle here. And so we can use the Pythagorean theorem once more. And if we do so, now we're going to look for the hypotenuse, so we're going to look for C. And so we can write, the bottom side is 2, so we'll have 2 squared plus the other short side is root 3, so we'll have the square root of 3 squared, and that is equal to our hypotenuse EB squared. And now we can feel like we're getting closer to the end because EB squared is precisely what we're asked to find. Now, 2 squared is 4 plus the square root of 3 squared, the square root and the square cancel out, and so we simply get 3 is equal to EB squared. And then finally, putting it all together, 4 plus 3 means that 7 is equal to EB squared. Our final answer. Okay, so I hope this was helpful. I hope this was a nice kind of way to use the Pythagorean theorem in a more complicated situation that might not be obvious right away. Asks us to use some facts about geometry that we don't often get to in school, or not, at least not as much as I think we should. So here we are. If you have any comments, suggestions, please leave a comment down below. Any requests for future videos, always appreciated, and thanks for watching.